Hi there. Today we will try to create a simple personal expenses database, and this can be a great tool for recording expenses instead of writing it in a notebook. For me, I would like something that I can easily input or update my expenses, categorize it accordingly, and have a quick visibility on how much I spend on that particular category. Okay, so let's start. Our first step is to create a conceptual design. In the conceptual design, this is where we build the conceptual data based upon the identified requirement. Here we're using the entity relationship diagram to create a graphical representation of the entities and the relationships between them. First, we identify the entities, and for our case, we have the person, the income, expense, and the category. Then we assign the attributes or the properties to all the entities. For example, entity person, we have the ID and the name. The expenses, we have description, amount, expense date, and so on. Relationships are the association between different entities. The person records expenses, and here, records is the relationship. It is also shown in a diamond-shaped box. And then finally, the cardinality notations define the attributes of the relationship between the entities. In our diagram, one person has multiple income, and the other cardinality can be optionally one to one, one to many, and many to many. Okay, next is the logical design. Here we transform our ERD diagrams to a relation. Remember that for a table to be a relation, it has to have the following properties. Okay, first step is to represent the entities. This is very simple. We just need to map the entity type, which contains all the attributes, directly onto the relation. Okay, this is the resulting relation schema. And next, representing the relationships. Let's take a look at the diagram again. Here we use the primary keys and foreign key to maintain the relationship. And for one-to-many relation, primary key on the one side becomes the foreign key on the many side. And applying this rule, here's our resulting relation schema. Third, we have normalizing the logical design. Okay, data normalization is used to improve the logical design. This to avoid the duplication of data. There are 5 steps in normalization, but we will just focus on the second normal form. The rules are there should be no multi-valued attributes, and every attribute should be atomic. And then if you look at our relation, so far the defined attributes are correct. Also, every non-key attribute is fully functional dependent on the entire primary key. For example, in the expense relation, you can determine all the values for non-key attributes, amount, description, and expense date by knowing its expense ID, which is actually our primary key. Okay, lastly, we will create our database and run SQL queries. First, we create a database. Then we create our tables, and let's add new entries to all our tables. Okay, and then we will try to edit the rows in our table using update statements. Be careful on updating the data in the table. Notice the where clause, which filter the results to update the rows that satisfy the condition instead of updating all. And then similarly, we can remove rows in the table by using delete statements. Okay, and then lastly, here are some queries that you may find useful. If you notice this query, left join is used to combine rows from different tables. To calculate the total income, expenses, and savings per person, you can actually run these queries. If you are thinking to create a web app with this DBMS, the simplest and the easiest is to use databases like MySQL. I think that would be fine. And then for writing the UI and interacting with the DB, you can use simple programming language such as PHP.